and welcome to the Aerospace Testing podcast. I'm Ben Sampson, editor of Aerospace Testing International magazine. In this month's podcast, I talk to David Mayman, CEO and founder of JetPack Aviation. David's company is one of, to my knowledge, only two in the world that makes and sells jetpacks today. But their latest product isn't a jetpack. It's a jet-powered eVTOL called the Speeder that looks like a motorbike you ride in the air. It's an intriguing and futuristic looking concept that borrows technology and learnings that the company has gained from its jetpack range. As you'll hear, testing is progressing nicely for the company out in California. Like his company, David is unabashedly ambitious, an aviator at heart who has also flown a jetpack around the Statue of Liberty, which is something you don't do every day or talk to about someone every day. Anyway, I hope you enjoy the podcast and please do subscribe.
The background is we started with backpack-mounted, foot-launched jetpacks. We won a contract with the U.S. Navy Special Forces, the Navy SEALs on the east coast of the U.S. Back in 2016. And what we found by training their operators and flying them was that it just took too long to train somebody, basically, and the payload and the range was limited. So they said, what is it that you could build that could lift, say, 300 pounds and could fly for, over half an hour and do that at least, at 200 knots? And that's not something that you can wear on your back with existing technology. Certainly not electric. And then when you're talking about turbines, really you have to carry too much fuel and it becomes impossible for it to be, foot launched or backpack mounted. Mm-hmm. That's where the concept of the Speeder came from. It's still a very small vehicle, about the size of a motorcycle, but can carry up to 600 pounds, in fact, scalable to several thousand pounds and fly for a lot longer. And it can be flown fully autonomously. So the training required to fly it is minimal.
Okay. Well, let's take a step back just for a moment for perhaps the people listening that aren't familiar with the jetpack so much. I mean, at what point is that product at the moment? Is there people out there using it? Is the testing finished?
So there's different versions. We've already refined the JB-10 jetpack. That's the vehicle that we train the Navy Special Forces operators with. And then we moved to the JB-11 and JB-12 jetpacks. And instead of having one engine on each side, they actually have three engines on each side. So 6 engines in total. And you have redundancy in the case of JB-11 and JB-12. So if you do lose an engine on one side, that you can actually continue to fly, or at least you can land rather than having a very strong asymmetric event that may not be recoverable. And they are being operated now. We operate them ourselves for a range of things, events that people want us to fly at, movies, TV commercials. We run training in Southern California for anybody that wants to come to learn to fly a jetpack. And then we've sold a few as well, and recently sold some into a Southeast Asian country at the government level.
Okay, so how would you describe the technology for that? I mean, is it mature now? Are you still refining and developing that platform, or is it as good as it's going to get?
It's not as good as it's going to get. Uh-huh. The engine design will mature further for sure, and that will improve the SFC, the specific fuel consumption, and the thrust to weight ratio. There's no doubt that has got some way to go. And also the control systems that we use with the jetpacks at the moment are pretty manual. So when we train somebody to fly, it's kind of like riding a Segway. If anyone's ridden a Segway on the road, in as much as you can lean and lean forward or sideways and it will follow you, but it's not autonomous and it's not fully stabilized. So that's something that we're still working on.
Okay.
So you could go fly them now. You could do special missions with them, CASEVAC, etc. But we can take it further.
Okay. And you mentioned some of the applications there. Just quickly, I mean, that they're the kind of applications you're looking at. Are you kind of medevac and sort of emergency where you have to get in quick with somewhere?
Look, it's really any use case where you need to pull an aircraft effectively out of a suitcase. So it's just, you can't rely on a helicopter, for instance, because you can't take a helicopter with you in all cases, where you can pretty much take a jetpack and it's ready to go. It'll take you 5 to 10 miles, over 100 miles an hour. So a lot of the work that we did with the Navy Special Forces was ship to ship, small attack vessel through to larger vessel that may have been taken over by bad guys. And the options they have at the moment is hovering an MD 500 or Little Bird over the deck and rappelling down a fast rope. You're a pretty easy target in that case, or clambering up the hull of the ship, which is, and I've been out at night and watched them do those exercises, and that's about the scariest thing that I've ever seen. So, they're really interested in another option. Okay. Infill, exfill, getting a medic into place way faster than you could by road, and not risk a crew in a helicopter.
Okay, all right. So let's just cover off the jetpack, if I can. I'm going to ask you a question which I kind of regret asking. I know I'm going to regret asking because I'm sure you get asked it at dinner parties and stuff, or have done over the years many times. But what's it like flying a jetpack?
Bloody incredible. It never gets old, and it every time I get to fly one now, because I've got others that I've trained, so it doesn't happen as much as it used to. It's an extraordinary sensation because it's very small, it's very light, and you're strapping something on that can lift you off the ground, catapult you into the air at probably climb rates of over 2,000 feet a minute. And very rapidly accelerate to over 100 miles an hour, and then you can turn on a dime. It's like, the way I describe it, it's kind of like riding a motorcycle or even a push bike, but you're doing it in the air, and it's that maneuverable. Yeah. So it's a pretty special experience.
Whereas the speeder, I think I read in your website, you actually do you describe that as a motorcycle for the air? In fact, is that one of the ways that you?
Yeah. We do, and maybe that's it doesn't have wheels, okay? So it doesn't ride on the road like a motorcycle does, but it's kind of similar form factor to a motorcycle, or maybe a jet ski.
Yeah.
And the idea is that it's extremely small, so it's something that you could package and put in a car trailer or a motorcycle trailer and literally launch from anywhere, and that's the big differentiator against, obviously, traditional helicopters, but also any kind of electric propulsion craft. So whether it be one of the emerging eVTOLs or a heavy lift drone, they're roughly 10 times the footprint if you want to lift the same payload as our speeder, and they would still be 1/3 the speed.
Okay, right. So how much carry across in terms of technology is there from the jetpack to the speeder? Is it white blank sheet, start again, or?
The design was a completely blank canvas, but the way that we manage the engines we build all our engine computers in-house, so the engine computers are very similar. So the way that we balance the thrust across the engines is carryover technology. One of the things that we had to learn about is gimbaling the engines. So you imagine you're taking off vertically, but you want to end up flying very quickly horizontally. That's where you get all of the efficiencies of aerodynamic lift. In fact, you want to stay in the vertical position for as short a time as you can. So we had to learn about gimbaling the engines in 2-axis, and then also building jet evaders that fit on the end of the engine exhausts, also that can direct the thrust in 2 axes. So if you look at the the range of control inputs we have, it's pretty extraordinary. You have the gimbal, the engines themselves can be moved forward and aft and laterally, and then the same with the jet abaters. And then you have some degree of differential thrust. Of course, turbine engines don't spool up and down like electric motors on a drone. They're not instantaneous. There's some lag.
Okay. So how many? 2 engines, wasn't it? Or
on the speeder is 4. 4 on the prototype, and production would be actually planning on 8.
Okay. And what could you run through some of the specs? I mean, specs for that for me. I mean, what's that going to be like to use? I mean, how fast are you going to go? I mean, what's the thrust going to be like?
The thrust, depending on which engines we end up using, the thrust is roughly 100 kilos, so roughly 1,000 newtons per engine.
Yeah.
So we could end up with 8 of those. It does depend on which engine we end up using. And as I said earlier, there's a heck of a lot more development work actually to be done on these engines, and we'll probably end up using turbofans rather than turbojets. So in terms of payload, we're looking at a minimum of 600 pounds with full fuel, and approximately 25 to 30 minutes in hover and nearly an hour in forward flight. And the reason, obviously, the difference between hover and forward flight, the range or endurance benefit is just the aerodynamic lift we get, from the body and also from our little winglets. Okay,
and I mean, obviously, no one's been up in it yet. I mean, what in one yet? What stage of the program are you at the moment? You said you started in 2016. Did you say earlier?
No, the speeder started after we went through the Y Combinator accelerator program in Silicon Valley in 2019.
Okay.
So that's where we got the funding from to start the speeder program. We did our physics modeling and our flight systems development and all of the flying on a computer during 2019 and halfway through 2020, and then we started building the aircraft in 2020 and started the flight test program at the end of 2020 and finished the initial flight test program for the first full-scale prototype in May this year. And the first, you asked about, nobody's gotten to fly it yet except the computer. It is full scale, but no human on board at this stage.
So where are you at then with that? You said you completed it. So how far have you got with that? Has it been? You've tested it in what way? Has it been? I think I saw some video footage of it tethered and tested.
Yeah. So we started off. It's been an interesting journey for me. Just watching this compared to the development of the jetpacks. We started off with it indoors in a very big warehouse in Port Hueneme, just north of Los Angeles. It's a big Navy facility on a lateral tether line and a longitudinal tether line. So effectively, it couldn't really move that far. And it was like that for probably a month. And then we moved the lateral tether line and started allowing it to roll. But we still had the longitudinal tether line attached. And then we eventually took away the longitudinal tether line and just had one tether on top. The reason for that is it's our only test asset. We've invested pretty much all the money that we've raised in building this one. And the tether line doesn't help. In fact, it makes it more difficult to operate and to test, but it's there just as a safety line, just in case. So the videos that you've seen and the photos that you've seen, you'll probably see a single tether line on top, and there's a retractor reel. But once the speeder gets to a certain height, you can clearly see that tether line is completely slack.
Yeah. And I mean, what's the next step really in the testing? Could you give me an idea of the kind of roadmap that you're working to, or?
Yeah, sure. In the facility that we've got at the moment in Moore Park in California, we can only do forward transitions for like 90 feet. So it's very, very small. It's great for hover testing, which is really what we've used it for. But for transition testing, we need to find a another test facility, and I think we've done that now. So we're currently building our P1.5, so it's the next iteration after the P1. It's nearly finished. It'll be finished in the next six weeks-ish, and then we'll start flight testing that late summer, early autumn or fall. And then the idea of that aircraft is we'll start back to doing hover tests. Mm-hmm. I should say that the difference between the P1 and the P1.5 is that we've gotten rid of all of that bulky airframe that you see. If you've seen any of the photographs, you'll see that sort of 2/3 of the aircraft is this outer aluminium frame, and we had that there originally for connecting to the tether lines. But if you look at those photographs and imagine where the engines sit in that quadrant where the engine sits and the fuel tank sits in the middle, that's all that will be coming down to with the P1.5. All of the extra structure will go away. So we do need to go back through hover tests to check that the jet evader system and the gimbal system work on the 1.5 just as well as it did on the P1, and we're pretty confident that it will. Once we've done that, we're enabling differential GPS for the first time as well, so that will give us better position holding, and then for the first time we will venture off the tether.
Okay.
And start doing forward transitions.
Remote controlled, obviously, it will be a while before you put a human on it. I keep putting my hand up, and the investors and pretty much everybody else says, no, not yet. No. Has anyone else ever tried anything similar to this? Do you look to anyone else to do?
There's a lot of eVTOL players around, as you probably know. In fact, when we started, I think there were 5 in the market, including Volocopter and a few others, and I think there's over 300 now.
Yeah.
But I don't know of any other company that's got a turbojet or turbofan version of this. Effectively a poor man's F-35.
Yeah. Okay. Is there anything specific about the testing? There is a lot to do. I can see that. But is there anything specific that you could that the readers of the audience would find challenging? Particularly interesting. Obviously it's a very unique project. So I guess.
But one of the things that we had to write all of the code from scratch before we could start testing, because there's just no code libraries for turbine VTOL. The Harrier, the jump jet, is about as close as you get to what we're doing. But compared to eVTOL, where there's hundreds of thousands of code libraries, there's really nothing. So designing or writing that code, building it in the simulator, running it in MATLAB and Simulink, and then running it in the vehicle and going through that process in an iterative manner. That was very interesting to me as a non-engineer, just to watch how the engineers did that, and just how close it performed in the test environment compared to the simulator. The biggest challenge we've had is to create control systems that will react fast enough to hold position. It's relatively easy to create control systems that will enable the aircraft to do a slow forward transition. You can just gimbal the engines to do that. But if you really want it to hold position in a way that, standing there, you wouldn't even see what it's doing. It's doing it so fast. That was the real challenge, and that's where the jet evader system came in. So testing the jet evaders has been fascinating. First, we modeled that on the computer, the size, the shape, the mounting position on the engines, etc., the rate of movement. Then we had to understand the torque values for the actuators, etc. And then we ran them all on a test bed indoors, in a large warehouse at the Navy facility. And we had to build our own test bed system, because what we needed to know is how much lateral. So if you move the jet evaders one way, how much lateral movement does it create, or arm does it create? But also, what does it do to the thrust of the engine? How much thrust are you losing? And then can we use the fact that we are losing thrust perhaps as part of the control? And we tried, it was probably nearly 20 different jet evader versions on the test stand. And we built them all in-house, cut them, welded them, shaped them, etc. And we came up with what we believe still is the optimal balance between losing thrust and authority, a control authority, lateral control authority. And we having test that on the test bed indoors, simulated, that's what we've mounted on the speeder. But it didn't work out exactly as well as we had simulated. So there's still been a number of small improvements made to the jet evaders, like literally taking them off after a day of testing, using the laser cutter to cut down one side, retesting that. That's been our single biggest challenge is refining the way that those jet nozzles work.
I was going to ask, could you explain what a jet evader is to me?
Yeah, if you imagine the engine exhaust, obviously comes out of the engine combustion chamber, and then you have the engine exhaust, which is the exhaust pipe, and we get direct thrust out of that.
Yeah.
But what we want to do is be able to direct that thrust, direct that exhaust one way or the other, and to do that, we place a 2-axis nozzle system at the end of the exhaust. It actually starts at the top of the exhaust and then runs down the exhaust, past the end of the exhaust, and entrains the air as it comes out of the exhaust system. And we can duct that forward, aft, or laterally.
Okay.
And as I was saying, just perfecting the angles of that, the lengths of that, was quite an exercise.
Okay, cool. All right, it's really interesting to hear about that in that much detail. Thanks. Just to kind of finish up, really. I mean, the future. I mean, what's I'm reluctant to ask you, but how long do you think until someone's up in the air in a speeder? That's not you. That's not you.
I think I might get away with it one night. I shouldn't say that with all these sightings around LAX of jetpacks and all that kind of thing, because that's not us. So
there must be a kind of time frame. Are you looking?
Yeah, no, there is. For manned flight, I think we're going to be late next year, sort of third quarter next year. We'll be doing some basic manned flights.
Yeah. Okay. Cool.
Yeah.
All right. And what about the future? Yeah. What about the future market? I mean, obviously, you mentioned the growth in interest in eVTOLs, which is, I mean, there's the classic. I call it classic now. It wasn't classic at one point, but the hype curve of interest in the technology, and I mean, we're losing projects all the time on that, and only a few will survive. What's your take on the future market for this stuff? I mean, are you aiming for a kind of a niche defence application first, similar to the jetpack, or can you see wider applications for this?
I think there's several phases for us. I think that there's no doubt initially there will be a military opportunity for us, given we're already working with the Army and the Navy and the Air Force in the US. I think that it's the only vehicle that they can take along with them, at all times and have access to without having to call a helicopter unit in. So I think that for very high speed, ultra high speed cargo delivery of 600 pounds and up, I think that's a use case, and we'll be able to do that within a couple of years. I think exfil, infill, and Medivac is an option. And that's, this is not for secret forces when they're doing covert ops. This is when you're in a contested environment, and access and speed can save lives. That's where I see this being used. So initially DoD in each of the branches for those use cases, and then I believe in the civilian context, firefighting is a great use of our vehicle. If we could scale to carry over 1,000 pounds of fire retardant, it's a vehicle that could technically be carried by the firefighters at all times. They could trail, having a trailer, several speeders. They could launch them again well before a helicopter can get onto a fire. We could do that autonomously. So these days, we know where the fire is. We can drop the fire retardant very accurately. We're not worried about wind. Literally, the jetpack and the speeder is probably the least affected aircraft from wind. We've already flown in over 30 knots. It's just not affected by wind. And in like very, very bad visibility that you'd never want to put a helicopter pilot through. So I think firefighting is a great one. And then Medivac, or the movement of medics. We've partnered up with the world's largest EMS company. And the reason that they're interested in working with us is that they get the need to move medics by air. And the problem with eVTOLs is that they're just too large in a dense urban environment to be able to land close enough to target. And they did a $1 million study with McKinsey, and they worked out you have to land within, I think it's 200 feet or 300 feet of target, or the medic may as well have gone by road. Mm. You can't do that with a helicopter or an eVTOL, which is bigger than a helicopter. Mm. So I think that they're the first two phases. And the third phase for us, probably when we do go electric, will be a 2-seat urban air mobility solution, a very high speed 2-seat taxi-like service in UAM.
Okay, yeah, I'm fascinated by it, and I think it's a great project and so interesting. It's great to hear you talk about it in the way that you had, David. It's fantastic, and thanks for doing that. Can I just ask? Is there any time when you kind of feel like, my God, what am I doing here? This is like something out of some sort of 70s Bond film or something, is it?
Yeah, I do sometimes. My kids remind me as well. Some of the dreams that I had originally have come off. So I have, some really great aspirations for how we can use these vehicles. Yeah. I think we can make them happen. So yes, I'm still sort of pinching myself and saying it's amazing that we've gotten this far. There's so much further that we can go, and it's exciting. It's really exciting time to be in aviation.
Absolutely, I agree. Okay, well, thanks again for your time, and good luck with the project. So I hope you enjoyed listening to that as much as I enjoyed talking to David. It's great that he firmly believes so strongly in his futuristic speeder concept, and I think that comes across when he talks. And I also think he has the drive to succeed in developing it and the support to progress it. Be good to know what you think. Anyway, thanks again to David Mayman for his time and to you for listening. Have a great day.